everyone. Um, Welcome to what is our first general 3-4 sort of head start revision lecture for Unit 3 that's pre-recorded. So it's a little bit different to usual. My name's Josh and I should be in the chat right now, so hello to future Josh. And this is pretty exciting. So start off with just some general information. Obviously my name's Josh. You're here for general maths, or as some of you may know it as further maths. Make sure you're in the right Premiere, or you're watching the right recording. Today we're going to go through a bit of Unit 3 revision. We'll go through exactly what we're going to go through in a second, but we'll mainly focus on financial. We are going to spend about half and half, but obviously data's a lot bigger, so we're not going to dawdle on data. We're only going to go through it in about 50, 60 minutes, and then we're going to spend most of our time on financial. Other than that, this is 2 hours. If you have questions, please use the chat function. I'll be there for the Premiere, so you can say hi to me and ask any questions that you have. Otherwise, just to quickly move on, I better get my slides working. Just quickly, you're obviously here today to watch an ATAR Notes lecture. So I work for ATAR Notes, funny enough, and ATAR Notes is a company that's been around for a very, very long time. It's been around since about 2007. I remember attending these lectures in what would have been 2017 and 2018, back when they were in person. Things have changed with COVID, so we've gone online, sort of live streaming, and we found that maybe going to the recording format is probably going to be a little bit better for us, and we think it'll be better for all of you because it'll be more streamlined. There's more content rather than sort of pausing and breaks. You're going to get the same amount of content in 2 hours that you were getting in 2.5. And for those of you watching the recording rather than the Premiere, you have the ability to sort of stop, pause, do questions if you want, go back, rewatch things. We just think it's going to be a better format for the future. So ATAR Notes offers a whole bunch of other things as well. So we have obviously our study notes. We have free study notes online on our website. We have all the past lectures that we've run. We've got discussion spaces like forums. We have other videos that explain different topics, and all these other features here. And we've also branched out into some sort of paid resources that are a little bit stronger in terms of their sort of individual targeting. So for TuteSmart, you can get tutoring, you get one-on-one tutoring, you get class tutoring. So you can sort of pick out what you want and sort of get your targeted help. And then we have study guides, which I'm sure you've all seen. The study guides, the ATAR Notes ones, it's pretty much what made this company famous. And then you will also find our Ed Unlimited, which there should be a promo for down below. And you'll find that for the Premiere people, and you'll find that Ed Unlimited is our new sort of kid on the block. I say new, it's been there for about 3 or 4 years now. And essentially it's like the study guides, but online. And you pay a monthly subscription and you get all of the study guides, which is pretty cool considering you don't need to pay for all the study guides. You just get the ones that you want. So just looking forward to what we're going to go through today. So essentially today what we're going to go through is we're going to go through a bit of data analysis. Now, data analysis is huge. It's double the size of all the other modules in, I'm going to say further a lot, but general. We're going to skip univariate, which is the basic building blocks. We're going to fly through bivariate, and we'll spend a little bit of time on modeling linear analysis and time series, but we're not going to dawdle on it. We're going to push through it. It is going to take us about an hour to get through that content, but you'll find we're moving very quickly because there is a lot of content. That's not the focus of today. That's really just so you can go get a little bit of revision, touch on points and go, maybe I need to study that a little bit more. Move on. Then we're going to focus mainly on financial. Yes, financial is going to be the same amount of time as data analysis, but financial is a lot smaller. So focusing the same amount of time is going to be a lot more time essentially on financial. And then we got some tips and advice at the end. I allocated like 10 or 15 for that, but we really don't need that. We really only need 5 or 10. So if we run a bit over on the other topics, that's perfectly fine. That's the structure of today. As I said, this is not like rigid. This will be fluid and this will change, but there's sort of 3 blocks to today. There's going to be no breaks. So if you want to take a break and you're watching the recording, just pause and move on. And then just a little quick bit about who I am, or who am I. So my name's obviously Josh. I graduated in 2018 with a 98.2. It's a very long time ago, but I undertook further. I undertook that in year 11. And in doing that in year 11, that was 2017, I achieved a perfect 50. A very long time ago now, but I've been tutoring it ever since. I actually did a little bit of tutoring in year 12, funny enough, while I was sort of doing year 12 topics as well. And I've pushed through and done tutoring for the last 4 and a bit years, both privately and now through TuteSmart, which is the ATAR Notes company. And it's just something that I enjoy doing, and it keeps me upskilled in sort of all this sort of content. But a little bit about me. I'm from Bendigo, and I have 2 adorable pets at home. So I have my dog Maya, as you can see there. She's a 30-kilo nutcase, and then I have my very oversized elderly cat, and her name is Bella. And then a little bit about me in Melbourne. So I'm now a medical student. I'm undertaking a research year. As I'm 4 years into my medical degree, I've got 1 more year to go, but I've decided to sort of do an interim research year this year. So next year I'll do my final year, and then I'll be a doctor. These are my current tabs on my two work tabs. So this is what research looks like. It's just a lot of tabs and a lot of mess. But that's what I'm doing at the moment. And I know that's going to cause a few of you pain looking at that and going, that's not organized. Nonetheless, we're going to jump into block 1, which is data analysis. Just going to quickly check we are recording so that I'm not. Yep, we are recording. Good. Just wanted to make sure that we were all guns blazing. So we're going to jump into data analysis. We're going to start off with univariate, or bivariate, sorry. You're going to find that we're going to fly through. There is a little bit of univariate to start just because this is sort of high yield univariate, but we are going to fly through sort of bivariate, and then we're going to jump into sort of linear modeling, time series, and then really financial. And you can see where we're at down at the bottom of the screen. That's going to give us our little subheadings as to where we're at. And there are approximately, just to let you know, there are 114 slides, but the content ends at slide 98. So 98, take 9. There's about 89 sets of content slides to go through. And then we get to tips, and then there's just a couple of little slides at the end. So we'll start out. Normal distribution. I'm sure you've all been through this, but we need to know a bell curve. We need to know it well. With the bell curve, I think the most important piece of information that you can understand is that it's 50-50 on either side, and the middle is mean, median, and mode. That has come up before in an exam, and you just need to know that they're all the same. When you have normal distribution, these are all the same. This is the middle for median. This will be the average for mean, and this will be the most common because it's the highest up here for the mode. Symmetrical, all that sort of fun stuff. Approach 0 on either end. Really important to understand sort of standard deviation and the spread. So as you can see here, you're going to have, as you've got here, you've got a mean of 5. So if you come back here, you've got a mean of 5, and you've got a standard deviation of 2. So you've got 7, you've got 9, you've got 3, you've got 1, etc. And as you can see here, it says, all right, what is 1 standard deviation above 7? What is 2? 9. What is 1 below 3? Pretty sort of straightforward stuff, but just understanding our mean and our standard deviation. This is, and why I wanted to touch on this stuff just quickly before we jumped into bivariate. This here, this diagram, this exact diagram here, you search up bell curve distribution. This will be one of the diagrams that comes up on your image, Google Images. This is a diagram that is a non-negotiable in your summary book. Non-negotiable. This has to be in your summary book. This exact diagram is what I ask for with all my students. I don't want you to go, I say, feel free to draw your own one out, but this one needs to be somewhere. And you're all going to be handwriting your summary book. I hope all of you are handwriting. I'm a big advocate for not typing out one. I get it can be better in terms of, pasting things in and all that sort of like, formatting, but it's much better to write one out. You sort of learn as you write. You're not going to learn as you sort of type. It's a really important thing. But this diagram is a non-negotiable for my students, and I'm going to make it non-negotiable for all of you. It needs to be printed, cut out, and pasted into your book. Really, really important. So this is a non-negotiable. It's around 68% of data values lie on this 1 standard deviation of the mean, and then it tells you, 95, and then 99.7. It tells you how much is lying in between. It tells you the values for each little box here. So you've got your 34, you've got your 13.5, you've got your 2.35, 0.15. This is a really good diagram. You don't need to have this stuff here. You just need to have this diagram here. That's all you need, and that's what's really important. Then the last point with this is just have your formula for your standard deviation, your Z-score. So your Z-score does come up pretty frequently. It has come up in most exams at least once in either the multiple choice or the short answer. There's usually 1 mark allocated to this for the whole exam, the whole 2 exams. So it's 1 mark out of 100. There's, it's 1%. Make sure you get that 1%. You want to get every percent you can. So really important you cover that. The other point here is that you can manipulate this. For those of you who probably do, there's probably some of you out there who probably do a little bit of methods, maybe some special, or special. This stuff should be pretty straightforward, sort of manipulating the equation for the algebra. If you struggle with this stuff, like manipulating the equation to get different things at the front, try and have all the different ones that you can. The other one that's really going to be common is the actual score. You're never going to be really finding the mean or the standard deviation, the things that are given. But if you are sometimes asked to find the actual score from the Z-score, this is how you do it. You have the actual score at the front, then you have, your mean plus Z-score times standard deviation. So let's jump into types of data, and we'll jump into bivariate. So bivariate means there's 2 variables. It just means that you've got 2 things you can manipulate. So obviously if it's categorical, you're not going to be able to manipulate it as well, but I find this diagram really, really useful. So this one here, I always say to my students, again, have a diagram like this in your summary book, because if it ever comes to you, and it's more likely to come to you in a SAC, so those of you who haven't had your SAC for this yet, it's more likely to come to you in a SAC that you get data and you're asked to write it out. You're asked to display it in a graph. It's not really as much an exam question because it's a bit varied, and there's a bit of variability as to how you can mark it, and then there's it's a bit of a waste of time for an exam. For an exam, they're going to give you a lot more specific in terms of how to go about this question. For this is a SAC type question, but I think it's really important to have it in your summary book nonetheless, because it could be a multiple choice where they say, you've got these 2 variables, what's the best way to display it? So you need to know how to display data in terms of what its category is. So is it a categorical, is it numerical? And then your ordinal and all those sort of things. So what's really important here is you've got categorical, you're going to use a segmented bar chart. You've got numerical, categorical, parallel box plots. Your numerical, categorical, you've got back-to-back stem and leaf, and then you've got numerical, which is scatter plots. So just going to quickly fly through these. I'm not going to spend too much time on them, but these are how you sort of display them. So you've got your segmented bar charts, you've got 2 categorical. So you've got your cold, mild, or hot, and you've got your year, which is technically categorical, even though it's a number. It is categorical. It displays something. It's like a postcode. Categorical ordinal is really important. As you can see here, you've got a key as well, and that's really, really important. The key is super important for segmented bar charts. The other thing that's really important for segmented bar charts is that they stay in the same order. So they go hot, mild, cold. Really important they stay hot, mild, cold. You don't just want to suddenly go, all right, mild, cold, hot. You don't want to do that. You want to make sure they stay in the same order if you ever are to draw one of these out. You don't need to use different colors, but it is preferred. It makes it a little bit easier to understand. You just need to have them different. So if you're using one color, like you've got a pencil, and one thing, I do not recommend using pencil ever in an exam or a SAC. I know you're taught all through your life, use a pencil for maths because you can rub out a mistake. In an exam, no. You want to be using a pen. Let's just say for the sake of it, using a pencil, or you only have a black pen and you're making a segmented bar chart, just give them, well, that was not meant to happen. Just give them patterns. So as you can see here, give them patterns. So the bottom one, I do nothing. The top one, I go like this, or the middle one, I go like this, and this one, I go like this, and I give it a pattern. I just give it a different pattern. That was probably not the greatest pattern to do, but I give them a different pattern, and then in my my key, I say, all right, this means, X, this means Y, and this means Z, something like that. So you've got yourself a key. So you are completely within your right to do something like that, and it's important that you do differentiate them. You don't just draw out a bar and go, all right, you got this, this, and this. That's not useful. So then two-way frequency tables, these are pretty straightforward. I don't think I need to go through them in too much detail. The only difference is you need to have totals on them, particularly on the bottom, but you can also have them on the top, because as you can see here, this is more your explanatory variable. These two are your explanatory variables. This is more your your response variable. So these are explanatory and these are response. So really important that your explanatory variable goes on the top, your response goes on the side, and therefore you need to have your totals at the bottom rather than at the ends, because these are going to be 100%, these are not going to be 100%. So, awesome. Back-to-back stem and leaf plots. So these are quite useful because you can sort of display two pieces of information on the same graph, and you've got the same sort of set of numbers. So as you can see here, you've got this being your axis, and your axis is kind of staying the same for both of them, and then you just put your numbers in. You can sort of compare trends, you can compare everything that you really want to compare here, trends, your shape, your distribution, all that sort of stuff. What's really important about this is that it hasn't been displayed here, but you need to understand, what is this? Like, is it the age of the person? Is it the height of the person? Is it the weight of the person? Like, what is this? This one doesn't have that, which is a bit of a red flag. So this wouldn't get you full marks, because like, what's going on here? What are we looking at? Are we looking at age? Are we looking at, what are we looking at? It doesn't tell you, so you need to have that. And that's one of those key things, is giving a name to your graph. So this needs a name. So you need to say the weight of people with blue eyes, or the height of people with blue eyes in whatever it is, centimeters. This key is useful, but this key also doesn't explain what is the units. We don't even have units here. So you need to have in that key, you need to have the units. You also need to have like, what is going on? Like, what is the name? What are we looking at? So this one here would lose marks. This would definitely lose marks because it doesn't give you what you need. And again, key is really important. You need to have a key, especially for these ones, because 1, 0 could mean, could mean 100, could mean 10. It doesn't really tell you. So one categorical variable, one numerical variable, and you have to have them on the same axis again for parallel dot plots. So what I mean by that is, you need to have the 9s lining up, the 10s lining up, the 11s, the 12s, the 13s, the 14s, the 15s, the 16s. Again, this would fail because it doesn't give you a key, and it doesn't give you a name. What are we measuring here? Are we measuring test scores? Are we measuring, beep test scores? What are we measuring here? We haven't been given a measurement, like we haven't been told what we're measuring here, and we haven't been told what a dot refers to. A dot here could refer to 5, could refer to 5 boys and 5 girls, could also be just 1. We haven't been told that. So again, we need a key for this, really important, and we need a name to give context to what is going on, because we haven't been given context, and without the context, we don't know what's going on. So that's parallel box plots for you. I think what's really important here is that we jump onto sort of how we discuss these. This is probably the most important part of bivariate, and we're going to use parallel box plots for this. Now, parallel box plots, I haven't got a slide for it. Same thing as this, except you've got the box plots above each other, and you don't need 2 sets of axes. You don't need this axis and this axis. You're only going to have 1 axis, and you can see it sort of here. You only have 1 axis, and you've got your score sort of distributed out. So really important, comparing distribution, you can be asked to compare data sets looking at graphs. Most commonly, it's going to be box plots and scatter plots. Now, scatter plots, we use a completely different way of discussing them, so don't worry about scatter plots for this. This is covering everything else, so mainly box plots. What we need to look at is center, spread, and shape. Now, I'm going to add in an extra step here. I'm going to add in context at the start. You need to mention context. These 3, they're interchangeable in the way that they go. You can put them in any order you want. Doesn't really matter. I don't care if you go shape, center, spread, or you go spread, shape, center. Doesn't matter. What you need is context at the start. So you need a context as to what is going on. So I've been given box plots that say these are box plots. Compare the beep test scores of boys and girls in a class. So you need to say that when you're describing. You need to say what's going on. What am I actually discussing? Because if I just start discussing numbers, it doesn't look great. I'm just discussing numbers with no sort of rhyme and reason as to why I'm doing that. So you need context, and it's one thing that isn't on this slide, and I don't actually think it's in this example here. You need to have context. So Here is a set of box plots. You've got a score. Let's just say this is a test score. And you've got boys and girls, and we'll say this is in a class. So I think what's really important here is you need to say at the start, like, the following, I'm just going to write the following box plots, so parallel box plots. You're obviously not going to shorthand it like this, but I'm just shorthanding it for the sake of time. The following parallel box plots displays the test scores for boys and girls in a class. Full stop. So obviously I've just shorthanded that, but that's what you want to say at the start. So if you want to get your full marks, you need to give context. You need to refer back to the question. I know this is particularly something for science students. Obviously I do a bit science tutoring. So for me, it's a big thing, much bigger because it's a much bigger aspect in science, but it is a thing in maths as well. You need to give context. When you have a question and you've been given data or information, you need to go back to the context and say, what is the context of this data? What's actually going on? And then describe the numbers. So here, if you take out that context, all you've got is the distribution of boys' scores on the test are negatively skewed, whilst girls' scores is positively skewed. There are no outliers. The median score for boys is higher than for girls. The RQR is smaller for boys than girls. The range for the scores for boys and girls is equal. That means nothing to me. I need to know what's going on. So you need to give some context. You need to say, hey, the following parallel box plots displays the test scores for boys and girls in a class. Full stop. That's all I need to say. It gives context. It tells me what's going on, and then you move on. So as you can see here, this has been a really good descriptor because it's, other than not having the context, which I've just added in, it goes through center, spread, and shape. So it goes through the shape first. So it talks about the skew. And we all know that sort of positively skewed skews out to the positive, negatively skewed skews out to the negative. So it skews out towards 0, and then, you have symmetrical if it goes like that. As it says here, the girls' score is positively skewed because, as you can see here, it's skewing out here. I should have put those lines on the wrong one, sorry. Made that more confusing for everyone. It skews out towards the positive. The longer sides are at the positive end, and then you see the boys is negatively because the longer sides are at the negative end. So it's skewing out like that. So describes that. It also describes that whether there are outliers. That's just an extra thing. It wasn't really mentioned before, but it's something that's important to mention. Then says the median scores. So it talks about the center, the median scores, and then it discusses the IQR and the range, which is the spread of our data. So we've got spread. So we've gone shape, center, spread. So a different order to what we discussed before. It doesn't really matter that order. The context is the only thing that needs to stay in the same place, and that's at the start. So really important. That's how we go about it. So moving on. This is where things start to get a little bit more difficult and they start to get more important. This is bivariate data, and it's super important that we understand that scatter plots are just the next step on in bivariate data, and it's numerical. So we have numbers on both axes. We've got a y and an x. You've got your explanatory on the x. You've got your response on the y. So, if you have things like time, it's always going to be on the explanatory, which is the horizontal, and the x. And then whatever it's compared with will be on the y or the vertical. So when describing scatter plots, we go 3 key features. Again, there is a 4th key feature, and that is context. You must always give context. So I'm going to give context first, but for here, we're just going to discuss really these 3 other features, which are strength, direction, and form. So first of all, let's talk about our R value. Our R value is our Pearson's correlation coefficient. It measures the strength. So step 1 measures strength. Strength of a linear relationship. We generally assume everything is linear. There are some cases it isn't. We'll get to that, so don't worry. And we always find the value of R using a calculator because the formula for R is atrocious and we're never going to touch it. So please don't worry about the formula for R. As you can see here, we have a nice little table here that I would recommend having something like this in your data booklet, in your summary book. Sorry, I'm going to keep saying data book, I mean summary book. You need to have something like this in your summary book. Why is that? Because as you can see here, it just tells you when you describe what the number as. So if you get a number for R, you can then just go to this page and go, all right, it was positive 0.8, 0.8 falls into strong positive. it was negative 0.44. Negative 0.44 is a weak negative. Essentially, the closer the number is to -1 or 1, the stronger the linear relationship is. It's got more strength. The further away from 1 or -1, so the closer to 0, the weaker it is. And when it's very close to 0, we say there's no association, so there's no strength. The sign in front of R gives the direction, so the R value gives us both. It gives us the first two. It gives us strength and direction. So, looking at this, we'll just have a quick look at this one here while we're here. Having a look at this, I want everyone to have a quick think. For those of you not watching the premiere, watching the recording, feel free to pause and have a quick think. What do you think the R value for this would be? Well, how would you describe the R value for this? Not what the number is, how would you describe it? So, take a quick think. 3, 2, 1. I would describe this as positive. I think this has got a positive trend, but I would describe this as weak to no association. It's weak to no association. It would definitely fall somewhere in here. It would fall somewhere between, I'm going to say 0 to 0.49. It's probably falling somewhere more between like 0. It's probably falling somewhere more between 0.15 to, 0.49. But I would say it's somewhere between that weak to no association. But if it was weak, it would be a weak positive because it's definitely sort of that way rather than that way. So important that you can decipher that by looking at it. You're never going to answer a question based off it, but it gives you sort of like, all right, I'm going to assume my R value needs to be somewhere around there. Now, if my R value ended up, I went and calculated an R value now for that data, and I got an R value of like negative 0.88, I know something's going wrong because I know I shouldn't have a strong negative association. I could justify it being negative 0.2 or negative 0.1, as much as it's outside of the ranges I wrote there. I could justify it still. I could say, all right, that's not unreasonable. I might recalculate it. I'll probably find it's the same value and maybe my estimate was a little bit wrong. And I go, all right, that's okay. But again, if I get a value of like negative 0.88 or like positive 0.72 or something, I know something's wrong because that graph does not look like that at all. So it's important to sort of be able to decipher it as well, looking at your sort of graph, like just having a look at it and going, all right, what's it actually look like? Like, what have I actually got? And have a look at it in that sort of form. So warning, can only calculate R values for linear data sets, and we will discuss that. Then we have form. So form is whether it's linear, non-linear, or no association. You're going to assume it's linear unless it looks really bad, or unless your R value is no association. So linear data follows a relatively straight line, non-linear has a curve, and then no association is where the data points are randomly spread and do not appear to be associated. Pardon me. And then here's a really good table. I'm not going to go through this about how to interpret R values as well. So obviously we discussed this, but then this is where you can sort of describe it. And you sort of just change the bold words there. You say whatever the Y variable or whatever the X variable was, and you can sort of just describe quickly what's going on. And this is a really good little table. I'd put this in your bound reference, summary book, whatever you like to call it, because it's a nice little way of describing what's going on. So I'd recommend getting a screenshot of this or writing it out yourself, sort of this sort of content. So let's have a quick look at this practice question. Again, I forgot to fix these up. I did this in the chemistry one as well. This is VCAR 2016. When I was converting these slides over, because we've sort of changed our formatting, these were white, and I forgot to convert them all to black and then move them up a little bit so that they came up on the page, but I do apologize. That's VCAR 2016. We've got question 3, which is the data in the table below shows a sample of actual temperatures and the apparent temperatures recorded at a weather station. A scatter plot of the data is shown. So we've got actual temperature and we've got apparent temperature. You'd say apparent temperature is how you feel, and then actual temperature is what the actual temperature is. Using the scatter plot, describe the association between apparent and actual temperature in terms of strength, direction, and form. So I have an R squared value of 0.97. So best way to go about this, grab out your calculator. Let's hope this has battery. It does have battery. And go 0.97 and square root it. So if I'm actually going to need to copy all of that. I'm going to square root it, and I get a value of 0.98. So my R value is 0.98, which is just 0.98, which is really, really large. So then I come back to this page here. So I flip to this page in my data. We're going to go, all right, it can be concluded that the y variable should increase as the x variable increases. And I want to say that what I have here, so what I want to say is I have a linear, strong, positive relationship. And then I would just write out, just for completion's sake, this little paragraph here. And I'd say, it can be concluded that, so the y variable, the apparent temperature should increase as the actual temperature increases. So I've given a little bit of context to both. That's really important, so you put that in these lines here. It may not be worth a mark, but for completion's sake, it looks a lot better on your page. So, moving on. Does a high R value mean one thing caused another? Well, not necessarily. And for example, like, you know, this is one of those things where it's like there's a casual explanation. Now, what's really important, this has been effectively removed from the study design. And the only reason I left this slide in, so there was like, we had like 10 or 15 slides on this and I got rid of them all. The reason I left this slide in is because I've noticed through sort of new content that's been created for this year that they still do just mention sort of, is this going to cause that? Is that going to cause that? And then sort of explain why this may not have caused that. They don't want you to use the intricate detail of like non-casual explanation, sort of those third-party factors that we used to discuss in further, and you'll find will come up in your exams, practice exams as you do it, because it was in the old study design. All you need to know is that sometimes an R value is misleading. Data is misleading. Data explains something that in common sense does not make sense. So sometimes you need to use, for further particularly, you need to use a bit of common sense. There'll be a question where they'll say, you know, you got these two factors and you got a really high R value, what's going on? You just need to say, it's likely that these are just coincidence and there's no real explanation for these two pieces of data being the same. You never need to use, you're not going to have to use formal language anymore. In terms of this, you're not going to use certain definitions because it's been removed from the study design. But I just wanted to sort of clue you all in that in case you got a question like that at all, in case you're doing old exams and things came up and you were reading it and you went, oh, this is super detailed and I don't think I've ever done this. You probably haven't, because it's new information. It's just been added. So please don't worry about it. If you're going through and you're struggling with this stuff, don't stress. So as you can see, it's just common sense, just general logic. So that's bivariate data. Cool. Moving on. Now, modeling linear association. So this is where we talk about all our scatter plots and everything to do with scatter plots. So when we talk about scatter plots, it's really, really important that we understand that they are used in everything and they are just the best way of modeling data. So whenever we can use a scatter plot, we will choose to use a scatter plot. You will notice it when you watch the news, when you read a paper, anything like that. Scatter plots are everywhere. So how do we come up with a line of best fit? So a few things. We take the residual. So as you can see here, you've got this line of best fit and you've got all your little dots here. So least squares line of best fit. What does the least squares refer to? The least squares refers to the distance between these, so the actual data point and the line of best fit. The distances between those actual data points and the line of best fit are all added up, and we say what line, so using all the different lines we can possibly put there, what line makes the least distance between the actual data points and that line, and that is the least squares. So, and that distance between the data point and the line is referred to as a residual. And that's really important. So it's referred to as a residual. So we then make sure that our line of best fit line minimizes the sums of squares of the residual, which is essentially just saying that the distance between the actual data point and the line of best fit for each of the points added up, it's the smallest number we can get. And that's what a least squares line of best fit means. Now, it works best if there's no outliers, because outliers would then skew all of that. Now, what's really important is that sounds really difficult. It sounds super difficult. It sounds like something you're not going to be able to do easily. So what's the best way of doing it? The best way of doing it is doing it on your calculator. Or if you're given the right pieces of information, doing it by hand, and we'll discuss that. So a least squares regression line, or a least squares line of best fit, matches this here. Now, a lot of you will have seen a line that looks a little bit like this before. This is exactly the same. They have just replaced M with B and C with A. And really important, they've put the A in front of the BX. It's a very minute detail. It doesn't actually change at all how the line operates. The line operates exactly the same. There is no change to how the line operates, but you have to do it. You need to make sure you put your C/A, which is your y-intercept, before you put your gradient and your x variable. Really, really, really important that you change that up. I know you're all probably used to y equals mx plus c, but you just need to flip it. That's just reality. It's just a very minute, silly detail that you just need to persist with. Make sure you're entering the variables in the correct order. A classic VCAR trick is to give you the y variable before the x, because usually the x goes before the y, and you always look at explanatory first and then you look at the response. Sometimes VCAR will do the opposite. They'll give you the y, so they'll give you the response variable, and then they'll give you the explanatory variable. They're trying to trick you. You need to just make sure you double check all this information before you use your calculator or answer a question. So there are two scenarios to this. These are the two scenarios. I didn't want to go through this in too much detail because I'm sure you've all been through this in super duper detail. Now, I don't know why this diagram goes away, but nonetheless, you've got the general line of best fit. The two scenarios are: one, you are given the raw data. You need to use your Casio. So I'm sure you all know how to do this by now, but you go to your spreadsheets, you put it in your spreadsheets, you go to linear regression, and you select linear regression. And once you've selected linear regression, you go forward with it. I'm sure you've all done that multiple times now, and I don't need to go through that in detail. So I'm not going to. Again, it's slightly different on the two Casios. I personally have always used the white Casio, the ClassPad, because that's what I used in high school and that's what I've tutored with. But I know a lot of my students in the past have used the TN Inspires, which are the black one with the smaller screen. Again, you can do it on both. You just use spreadsheets. There's no difference. So you're all on top of it. Now, the other point with this is then, what if I'm given statistics? I'm not given the raw data, I'm given statistics. I'm given things such as the R value, the, pardon me, the, I got something stuck in my throat. The standard deviation of X, the standard deviation of Y, the X mean, the Y mean. Therefore, you are going to use these formulas here. Now, I didn't mean to draw through it. Super important here. These are not given to you in the exam. You need to have these in your summary book. These need to be in your summary book. So again, another non-negotiable thing, you need to have these two formulas in your summary book. I've even explained down here what each of the things mean. So R is your Pearson's correlation coefficient. SY and SX are the sample standard deviations of Y and X respectively. X bar and Y bar are the sample means of X and Y. Now, what I mean by sample is that it's the standard deviation of Y, of the Y values. So we've got the Y values, and we did our own sort of linear regression to just like calculations to our Y values, and we got the standard deviation and the mean. We then did our X variables, and we got the standard deviation and the mean. And really important that you know that it's just of those, it's not of the whole set of data. So it's just of the Y's, it's just of the X's. So you know SY, SX, X bar, Y bar. Now, you need to calculate B first for obvious reasons. You need B in the A calculation. So you do B first, get your B value, and then you can go Y equals A plus whatever B is, like, 3.2X. Then you calculate your A, you find A is 4, so you go Y equals 4 plus 3.2X. And you've got your equation. So non-negotiable, that needs to be in your notebook, your summary book, sorry. Another non-negotiable page, you will be asked in your exam, I can guarantee it, to interpret either the y-intercept A or the slope B. You'll be asked to interpret it. What it means by interpret is to discuss it with words, discuss what is going on. These are the two sentences you use. The first sentence is for the slope. The first sentence is for the y-intercept. The second sentence is for the slope. So if you are asked to describe the y-intercept, you will say the y-intercept is whatever a. So the orange means you're going to manipulate that. You're going to change it. So whatever a is, let's just say it's 2. The y-intercept is 2, and then what is the units? Because you may be doing age versus height. So think about it. Age, let's say in years, is going to be your explanatory variable. Your y variable is going to be, we'll do height, and we'll do it in centimeters, and that is your response variable. Now, it makes sense. It makes sense your response variable is going to be height, because your height is not going to justify your age. Your age is going to justify your height. So what we say is that, sorry, the y-intercept is, I don't know, it could be 20 centimeters. 20 centimeters, let's just say it's 20. This means that the y variable, which is age, is 20 centimeters when the x variable, you'd actually probably, to be honest, you probably don't even need, if I'm honest with you, you don't really need the units here. You can just say that the y-intercept is 20. This means that this means that the age is 20 centimeters when this is the height. God, I'm having a little bit of since that cough, I'm having a little bit of a mind blank. So the y-intercept is 20. This means that the height is 20 centimeters when the age is 0 years old. So that's how you go about that question. Now, let's say the slope here is 15. So you gain 15 centimeters each year. So you'd say B here is 15. So the slope is 15. This means that the height, and now it's positive 15. So it's going to increase. You're not going to write increase / decrease. You're going to choose one. So you're going to choose increase by 15 centimeters for every 1 year increase in the age. So that's how you go about that question there. And that's how you go about these questions now. It's really important you have these 2 sentences written like this with different colors to show where you need to manipulate it. So obviously there also you need to use the word increase if B is positive and decrease if B is negative. And you just replace the word. So really important, these 2 sentences are another non-negotiable. So you need to use them. Then what we have is another non-negotiable, which is the sentence to describe our R squared. So our R squared is our coefficient of determination. This tells us what extent of X is caused, what extent of X caused Y, or what extent of Y is caused by X is probably the better way of saying it. So it's, for the example back here, it's saying what extent of the height, what percentage of the height is explained by the age. It's like a data calculation for it. Obviously, it's not going to be perfect, but it's a way of us using maths to say, hey, what sort of percentage of our height is actually going to be manipulated by our age? So we say the coefficient of determination tells us that R squared times 100%. So R squared will be, so back in that past example, it was 0.97. So you'd say it's 97%. 97%, and we'll say this is for our age and height, of the variation in the height is explained by the variation in the age. So this gives us our sort of sentence to describe what's going on with R squared. So if you are asked to talk about R squared, this is the sentence that you will produce. You will use this sentence right here. So R squared will always come out of the calculator positive. That's another thing that's important. We can tell if it's truly positive or negative by observing the scatter plot or the gradient. So important. Now, quick little point as well is residual plots. Now, residual plots, I'm sure you've been through them by now, but just to quickly note on them, residual plots are where we have data, let's just say it looks like this, and it follows a line like that. Now, What's really important is that when you then go to graph this residual plot, what you're doing is going, all right, this here is going to, so my x here is going to stay the same. The x and the x stay the same. That axis will stay the same. The y-axis changes to residual. So the y-axis here was whatever your y response variable was. It now becomes residual. And you essentially plot it according to how big these differences are. So I'm plotting it on this graph, and it looks somewhat like this. And then you sort of connect the dots, like, you know, you make like a thing like that, and you can connect the dots. Now, you don't have to connect the dots. It just sort of helps out sometimes. Just one of those things I like to do, sort of help it out. But what's really important is with a residual plot, what you can tell is whether your data is linear or not. So what you can say is when you plot out your residual plot, if it looks something like this, or it looks like this where all the data points are on the line, well, if all the data points are on the line, it makes sense that your data is linear because it's literally going to look like this. You draw a straight line through it and it covers all the points. That's clearly linear. Now, if your data looks like this and it looks like a mess, there's no real pattern to it, you also have linear data. You're happy that this original data here was linear. That's what you're saying. If your residual plot is a mess, it tells you that your original data was linear. You're happy with that. It's not perfect linear. It's like, you know, but it looks like that. And that's clearly linear data, and it looks like that. So you're happy with that. Cool. Now, what if your residual plot forms a pattern? What if it forms a little curve, or it goes like, you know, like this, or something else, or it goes like this? You can even have a residual plot, that looks a bit like this. That looks linear in sense. Like that's a residual plot we're looking at there, and that looks linear, but that's a pattern. And because it's a pattern, it tells me that my original data is nonlinear. So if you get a pattern of any sort, it tells you that your original data is nonlinear. And that's really important. So if your residual plot forms a pattern and the only pattern that's accepted is this pattern here, if it forms any other pattern, your data is nonlinear. So the only time you're ever going to really need to use this in an exam is to interpret a residual plot. They give you a residual plot like this, and then they ask you to interpret what's going on, and you say, there's a clear pattern to it, thus telling me that the original data is nonlinear. Or there is no pattern to it, which tells me that the original data is linear. Cool. That's all you're going to need to talk about with these. Nothing more, nothing less. Now, just let me plug my laptop in. I was charging my iPad while I used it. Shut my laptop. Awesome. So, moving on to the next step as well. The next step that I just want to quickly discuss is data transformation. I'm sure you've all been through this, but data transformation, this is my second diagram, I'm going to say. This is the second diagram that you pull off the internet and has to, for all of my students, it has to be in your summary book, no matter what, non-negotiable. You don't draw this one out. This one comes from the internet. You print it out, you cut it out, you paste it in. There are no negotiations to this at all. Why is that? Because it's the best diagram there is out there for this. Now, if your data looks a little bit like this, and you come to the realization it is nonlinear, and you're not happy with it, it goes in a pattern like that. And then a question asks, hey, you've got nonlinear data, so why don't you make it linear? Why don't you make it as linear as you can? So then when you make things linear, you can sort of look at trends and so forth. It makes it easier to look at. So for things like forecasting and so forth. So what you do is you go to this diagram and you say, all right, what curve of my circle does it match? It matches this one here. All right, I'm going to apply either one of these. I'm not going to apply all three. I'm going to apply either. Now, which one do I choose? Well, you do all of them. And the one that produces the highest R value, or the best R value, the one that's closest to +1 or -1, is the one that you choose. That's really important. The one that is closest to -1 or +1 is the one that you choose. How do I do that? Essentially, it looks a little bit like this. You apply your transformation. So you go, all right, I've got Y, I've got X. I apply my X squared transformation. I've applied my X squared transformation. This is my new set of data. I put that in my calculator. And what I do with that from my calculator is I linear regress it, and I get an R value. I then do the same. I take this data here and I go, all right, so I did X squared, which was this one here. So, or it was this one. Let's just say it was in this one for the sake of it. I then go and apply y squared. So I would then go, all right, y squared equals, and I do 1, whatever 4.5 is, 10 is 100, whatever 16. I don't have the numbers for that, so I'm not going to go and do that. And then what I would do is I would get rid of essentially this one, get rid of this one, and I would compare these two now. And I would look at my R value. And I compare the two R values from this one and from this one here. And I say, which one is the better R value? It's probably going to be this one. And I go with that as my set of data. And I don't use the y squared transformation. I use the x squared. And then as you can see here, that's what happens. Looks pretty cool. Really important, if you are to draw one of these out, you need to put the x squared or whatever transformation you did on the correct axis. So if I did y squared, I would have done y squared. Or if I did, if I did 1 over y, I say 1 over y, etc. Awesome. So, I don't know why it's not going forward. All right, that is modeling linear data. Let's move on to time series. We're going to try and get through this in the next about 9 minutes so that we're at an hour when we finish this and we can jump on to the next topic. So, just quickly, time series. It's the same as a regular scatter plot, except our explanatory variable x is time, and we connect data points with lines. So, as you can see there, we have all our data points and we connect them together. Most of the time series plots look pretty messy, and this makes them hard to read. So when we want to look at the trends of them, we decide that why don't we smooth them out? Apologies, I think something stuck in the back of my throat. All right. So we want to smooth them out. And so by doing that, what we're going to look at is two methods: mean smoothing, median smoothing. Now, I hope you've all done this by now, because I'm not going to spend too much time. But smoothing via mean, pretty straightforward. You get, so this is a 3 mean moving smooth. 3 mean moving smooth mean, whatever you call it. It's using three values. So what you do is you go, all right, I want this value, this value, this value, add them together, divide them by 3. I get my value. I would then move on and go, all right, 6, 13. So I go like 6 plus 13 plus 14. And I would divide that by 3. I'd go the next one, I go 6 plus 14 plus 6.5. And I divide it by 3. And I get a data value here and here. I'm not going to get a data value here because there's not 3 pieces of information. There's not a piece of information here, so I can't go 1, 2, 3. Same down here. I'm not going to be able to get one here. Now, you can also do this for 5 mean smoothing and 4 mean smoothing. Now, 4 mean smoothing is complicated, so I'll explain why. We'll do 6 in the middle here. We'll do 3, or technically 3. So, to do a 4 mean smoothing, what am I going to choose? Am I going to choose 1 above and 2 below, or 1 below and 2 above? You choose both. I'll explain. You go, all right, I'm going to go here. I'm going to go in the middle here and in the middle here. All right, so in the middle up here, apologies, I don't know why that's got stuck in my throat. I'm going to add 7 plus 13 plus 6 plus 14. I'm going to then go ahead and divide it by 4. Now, I get 20, 20. The answer there is 10 because that's 20 and that's 20. Now, for this one, I'm going to go 6.5. Oh, sorry, not that one. 6.5 plus 14 plus 6 plus 13. Divided by 4, I get 39.5 divided by 4, which I think will be 9.75. But we'll just check. What was it? It was 39.5 divided by 4, which is, it's 9.875, sorry. 9.875. And then you know what I do? I go 10 plus 9.875 divided by 2. Plus 10 divided by 2. And I get an answer of 9.94. That's my mean smoothed position. So it's an extra step. You need to do 2 steps. Whereas this one, it was 1 step. It was pretty straightforward. This one here, it's not. You need to do 2 steps. And this one's a bit of a pain to do. As you can see here, I cannot find one for this, 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 and this. So there's a lot of values you won't be able to do it for on the ends, but that's sort of how you go about it, and you use a table like this. Then median smoothing. Median smoothing is so much easier. You look at the graph and you go, all right, these 3 data points, which one is in the middle? This one's in the middle, so this is what it is. So as you can see here, we'll do this one here. So we're doing this data point here. So if I look at 5, I'm going to use this one, this one, this one, this one, and this one. All right, let's go from top to bottom. This is at the top. This is next. This is next. This is next. This is next. So what's my median? My median is the 3. So this data point here is going to fall there according to median smoothing. So that's where my next one would be. It actually wouldn't be a so, it would be a little x. That's what they've used. That's where it would be. And that would be my data point there. So that's how you go about that there. So it says, the question here is 5 median smoothing has been used to smooth the time series plot above. The first 4 smooth means are the 5 median smoothing values with X crossed on the time series above. And then I'm assuming that they want you to go and do more of them. I'm not going to go ahead and do all of it, but that's essentially how you go about it. You know what's really important with the 5 mean smoothing? You're not going to have a point here and here. You're not going to have a point here and here. So you'd only have to do 1, 2, 3, 4, 5 points here to get your 2 marks. So another way that can that we can help make data more easily readable, or looking at the trends and stuff like that. Readable is a terrible word, nonetheless. Is through the use of seasonal indices. So this is where things get a little bit messy. And what I like to say is try and step these out. Have an example in your book and go through the different steps in your example. Say, all right, I'm starting at step 1, then step 2, then step 3, then step 4, then step 5. And you look at those steps and you work through those steps like that. So sometimes we want to compare and make regression lines, say perhaps for sale figures for a business and for usually for time series data. However, seasonality can make it hard to accurately get a linear relationship. So to overcome this, seasonality, which is where maybe every Christmas you're looking at a department store, you get more sales. Makes sense. Or, you're looking at, I don't even know, you're looking at like a rental business, and a rental business in the start of the year when everyone's, moving around for new jobs and uni and school, that's when it's going to be most busy. So to overcome these effects of seasonality, we can de-seasonalize our data using seasonal indices. So seasonal index is the value over the season divided by the seasonal average. So if we add all the seasonal indices up, we should get the number of seasons we should get the number to equal the number of seasons. So generally this is 4 because we'll look at quarters. That's generally what we use. So what I'm saying here is you get the average of all the seasons, you divide the value of whatever season is. So let's just say you had sales and you had 100 in summer, you had 70 in autumn, you had 60 in winter, and then you had 90 in spring. What you do is you add those 4 numbers up, you divide them by 4, you get a value. So if I just did that very quickly, 100 plus 70 plus 60 plus 90, and I go ahead and I divide that by 4, I'm gonna get 80. So I get 80 as my value. That's my seasonal average. And then I divide each of the values by it. So I go 100 divided by 80. I go 70 divided by 80. I go 60 divided by 80. I go 90 divided by 80. And essentially, each of those is going to give me a value. When I add those 4 values up, it should equal 4. So what does a seasonal index tell you? And each of those are a seasonal index. What does a seasonal index tell you? So if I get a seasonal index of 1.3, so in case, let's just do the first one, 100 divided by 80. 100 divided by 80 gives me a seasonal index of 1.25. So summer gave me a seasonal index of 1.25. What does that tell me? How do I interpret that? A seasonal index of 1.25 tells me that the sales for summer were 25% above the average. So I get 25% more sales in summer on average. So that's what that means there. As a seasonal index of 1.3 during summer, so this is 1.3 for this one, tells us the figures are 30% above average. If the seasonal index is 0.87 for winter, it tells me that we are 13% below the average. So that's how we operate with seasonal indices. So then there's this really common question where they say correct for seasonality with seasonal index. Students always get this wrong. It's one of those ones that's really commonly screwed up, and it's one of the ones that you just have to learn how to do it to get it right. So if I have a seasonal index of 0.8, to correct for seasonality, we need to increase the figures for January by what? I want everyone to have a quick think. For those of you watching the recording, just pause and have a quick think. For those of you who are watching the premiere, just take like 2 seconds to have a think, like 5 seconds to have a think, like 5, 4, 3, 2, 1. So what did you think? Just what did you think the answer was there? What do you think you need to increase by? I'm assuming a lot of you, those of you who haven't done this, so maybe like 60% of you may not have done a question like this yet, would have said 20%. This is at 80, so it's at 0.8, so it's 20% below. So you would assume to get back to average, you need to increase by 20%. I'm sure that's what a lot of you are thinking. That's actually wrong. That there is wrong. How you actually correct for seasonality is you go 1 over your seasonal index, which was 0.8. If you put that in your calculator, so if I go 1 divided by 0.8, I get an answer of 1.25. What that means is I need 125% of what I have. I need to increase by 25%. Now you might say to me, but wouldn't that make the answer 0.15? So wouldn't that make it 105% of sales? It actually doesn't. What it's saying is I need 25% of not what the total sales, if I was at average, I want 25% of this. So if my sales are 0.8, I need to increase by 0.2. What percentage of 0.2 is 0? What percentage of 0.8 is 0.2? Well, it's 25% of it. So I need to increase 25% of my 0.8. 25% of my 0.8 is another 0.2. You add that on, you get 1. So that's where these questions are a little bit difficult. You just need to do this. Now, what if I was at like 1.2? Well, then you go 1 divided by 1.2. 1 divided by 1.2. I get an answer of 0.83. So therefore, I need to reduce my sales by 17% to get back to seasonal, to correct for seasonality. I need to reduce by 17%. So hopefully that sort of makes sense how that works, because that's quite difficult. Now, what's really important is then you can de-seasonalize data. I'm sure you've been through this multiple times, but seasonalizing data, you were going to de-seasonalize to get a line of best fit, and then you're going to re-seasonalize the data for your equation. Now, I'm not going to go through an example for this. Here are the formulas. What's really important is the steps. Just know how to do your steps, how to make a line of best fit when you have seasonality. These are the steps. These are really important to have in your data booklet, or your summary book or your bound reference. My other thing with this is it's really important to have a example with it and say, all right, this is the example for each step, and go through a big example. So, you calculate your seasonal indices, you de-seasonalize your data. So once you de-seasonalize your data, you fit a line of best fit to the de-seasonalized data, you make predictions, and you get de-seasonalized predictions, then you need to re-seasonalize those predictions to get the real prediction. So it's a long process, but it's something you have to do. So hopefully those steps make sense to those of you who have done it. If you haven't done it, those steps are not going to make a lot of sense, but we're not really going to go through that today because it's quite an in-depth thing and we don't really have the time for it, given I want to spend a bit of time on finance. So that's the summary of the rest of that. We are all done for block 1. Now, for those of you who are watching, not the premiere, watching this recording, please feel free to take a break, pause, come back, go to the toilet, take a break. As you're watching the premiere, you don't get that that joy. We're going to move on and jump into financial maths. Just checking, what are we at? We're at 1 hour and 4. So we'll hopefully spend about 50 minutes on this, to be honest. I think that's sort of what I wanted for this, and then 5 minutes on tips. I know I allocated like 15, but the tips will take us 5 minutes. So, financial maths. Recursion, it's a tiny bit of stuff you need to know. Financial modeling, most of the stuff you need to know. So we're going to fly through recursion because I don't love recursion, and it's just very basic, easy, not difficult, and there's usually like 2 marks out of the entire finance sections on it, so it's not worth spending time on. So First, let's get very familiar. You need to know your financial solver like the back of your hand. The financial solver is used for everything. Know where it is on your calculator. So for this white one here, I go to menu, and then you'll find that, I'll figure out where is it. You find there's a finance section, and you click on it and it comes up with this. Hopefully you can see that. You probably won't, but that's okay. There's a finance section in your menu. It's on the second page of your menu, unless these have changed, because I probably haven't updated mine in about 5 years. Really important, you know where that is. For the TN Inspire, I'm not 100% sure where that is, but you need to know where your financial solver is. Your financial solver should look something like this. It'll be a little bit different to this, but it needs to look something like this. You'll have N, your interest rate, your previous value, your payments, your future value, and then your PPY, CPY, which are a bit useless because we don't really ever work with them, but they're there. So the other thing that's really important is to understand your negatives and positives. When you use a financial solver, if your money is negative, you are giving it to the bank. It's saying, I know for us, when money's in the bank, given our bank system and how safe it is, it's a very hot topic at the moment, given all the banks closing down around the world. Australia is highly regulated, and our banks, that would very, very rarely happen in our banks. Our banks, when we give money to the bank, we think of it as that's still our money. We can just do what we want with it. We can tap our card. It doesn't matter. That money is still ours. What this is assuming is when you give money to the bank, yes, you can access it, but it's no longer your money. It's the bank's money. It's now the bank's money. So you're negative. You're giving your money away. When you get the money back, so when you spend that money or you get it back in cash or whatever, that's positive money. So when you take the money out of the bank, that's positive. You're gaining the money back. And it's really important you understand that difference. Please understand that difference for the sake of this. So that's your financial solver as well. And just quickly on the summary book, because I did want to just quickly put this in here. The reality is finance really does suck. It is the hardest section on the exam, period. It is the hardest section. And you will struggle to get your head around it at the start. That's just what happens with finance. And what the reality is with the summary book is it also kind of sucks. And one of the reasons I really detest the way finance is sort of taught is, and it's the way that the textbooks put it out. So the textbooks summarize all the sections, which is really useful. So when you go through a textbook and you do the questions, it's on each little question type or little subsection. That's really useful when you're learning things, and that's why textbooks are great. But for finance, the issue is when you get to exams, it's never broken up into little subsections. Unlike data and unlike your other modules, it's not broken into subsections. There is no subsectioning of it. They are no longer like that. How they are broken up is there's no breaking up. They mash them all together. And they make you figure out from reading the question, what formulas are you going to use? What numbers are you going to utilize? What's the actual answer they're asking for? What value are they asking for? That's the trick with finance. Finance is all about reading through your question and figuring out what you need to do and what they want. They are the two things you need to figure out before you start writing anything on your page for a financial question. What do I need to do? What do they want? They are the two things. And that's why textbooks I find with students, textbooks are great for the first half of finance. For the second half of finance, when you're starting to practice for SACs and exams, students get stuck in a rut. They go like this. They go, all right, I'm learning, and then it's like this. They plateau. They are unable to get to this is where they need to be, and they're unable to go, all right, I'm plateauing, and then jump up here, because they stick with textbooks. Really important. Textbooks ask questions broken down into subsections. You need to be, once you've done all the textbook questions and you're comfortable with all the different formulas, you need to start doing exam and SAC style questions where you figure out what you need. So I'm going to simplify things down, because then for your summary book, it's really difficult. For your summary book, you need, what I would say is, first of all, do it in your workbook. Each time you do a topic, make it a subheading and go simple interest, and then write down all the information on simple interest. Then do depreciation, then write down all the things for depreciation, financial solver, definitions, etc. Once each page is filled out with notes and examples, summarize it into your reference summary book. Now, that is breaking it up into sections, and you're going to say, well, that's not what you were telling me to do. I want you to do that so that you have the basics. After that, your summary book should consist of how do I work through examples that use multiple steps and are confusingly worded, because that's a lot of what financial is. It gets confusingly worded. It's probably a better way of saying that, but I'm not an English tutor. So that's really, really important to understand. So initially, your summary book should have each of the sort of sets or the little subsets sort of set out, and then after that, it needs to be how does everything intertwine? How does everything sort of come together? What are really tough examples? How do I sort of work my way through examples where there's multiple steps and I'm not really sure what I'm doing? That's what your summary book needs to look like after that. And that's a really important thing to me, is that you need to sort of have your summary book in a sense sort of broken down into two sections for finance. So that's sort of just my point. Now, we're going to jump quickly into recursion relation. We're not going to spend too much time on it. We're going to fly through it. That's that. So recursion relation, essentially where you generate terms and you have these little relations here. They look like Vn plus 1 equals Vn plus 3, and then Vo is 1. So then you go, all right, so the first value is 1, 1 plus 3 is 4. The next value, so V1 is 4. So then I go V4, so I go V1, so that's 4, 4 plus 3 equals 7. It's just very simple sort of maths. It just gives you things in an order. You can make them into nth term when they're just an arithmetic sequence where they just add up or subtract. There's no multiplication or division. And as you can see there, you go Vn plus 1 equals Vn plus D, whatever D is. Or you go Vn equals V0 plus n times D. So if you want to find the fifth term, you go 5 times whatever the D value is. So as you can see here, calculate U4. So in this case here, you've got U0 equals 2. So what you would do is you would go U4 equals, so coming back to this, you go 2 plus, and I wanted 4 times 4. So you get 16 plus 2 equals 18. Very simple way of doing it. So as you can see, you can go about it the long way like that, or you can do the nth term, and it's much, much quicker. So that's how you go about it there. So then you have geometric sequences, which are a little bit more complicated. Geometric is where they go up or down. And so they're either multiplied or divided. No matter which one it is, multiplication or division, if you use an nth term, you go R, which is the same value as it's what D was, but now we use R because it's geometric, R to the power of n. And so in this case here, as you can see, I want to find U4. I've got 2 as my original value, and my equation is 2u. So I go 2 times 2, 4 times 2, 8 times 2, 16 times 2. Very boring. Or I go u0, which is 2, times by 2 to the power of n, which is going to be 2 to the power of 4. 2 to the power of 4 gives us 16. You can just do that in your calculator. 2 times 16 is 32. Much quicker way of doing it. So that is essentially your recurrence relations. Then you have sort of this understanding that you can have a general linear equation where you have both an R value multiplying or dividing, and you also have a D value adding or subtracting. Really important, there's no nth term formula for this. You just have to do it. It's really a bit of a pain, but you've just got to go about it. There's no way of doing an nth term for it. You just have to keep doing it, as you can see there. So if you look at a sort of practice question for this, it says the first term in a sequence is 3. The second term is obtained by multiplying the value of the first term by 5, then subtracting 2. The third term is obtained by multiplying the value by 5 and subtracting by 2. Cool. This pattern continues. So we're multiplying by 5, we're subtracting by 2, and the recurrence relation which generates this sequence is. So the first term, which is T1, because it hasn't said it's the original term, which is 0, it says the first term, is 3. So they have to have T1 equals 3. They've all got T1 equals 3. Cool. Then it says the second term is obtained by multiplying the value of the first term by 5. So we need to multiply the first term by 5. So multiplying by 5 happens here, doesn't happen here. Multiplying by 5, well, that's negative 5, so that's not it. That's negative 5, that's not it. That multiplies by 5. Now, really important, how can I tell this one's the answer? Because the Tn plus 1 should be on this side and the Tn should be on that side. So that's correct there. The answer here is B. So that's how you go about a question like this. This is a pretty straightforward sort of recurrence relation question that I'm sure you're all on top of. So pushing on. The next step in this is understanding your financial terms. So this is a page I would expect pretty much all of you to have something like this in your summary book somewhere, so that if you are asked to describe a term that is in an exam, you can sort of come back to it and go, all right, this is how I go about it. Because this stuff can be quite difficult if you don't really remember the terms, and it can get quite confusing. So let's just quickly go over each of these terms. I'm sure you'll read through it yourself, but an investment, I'm sure you all know what an investment is. You put money into an account or an asset, and you sort of get money back. So the investment is how much money is being put into an account or asset by an individual. So it's sort of how much money you're putting in, and then you should essentially get money out. A loan is the sum of money that a person borrows from the bank that incurs interest. A principal, this is the initial value that was either invested or loaned. So it's the initial value. That's the principal is the initial value. The interest is a portion of money that is added every period, usually as a set percentage, increasing the sum of money owed or earned. So interest is essentially just money added on top. So if you give the bank money, they're going to give you interest because they're borrowing your money. If you steal money from the bank, well, you're not stealing, you're loaning, you're taking money from the bank. So they're giving you a loan of money. You are going to pay interest on top of that when you pay it back because they are giving you money. So then their way of making that profitable is you need to pay them a little bit more back. Essentially how a mortgage works. Withdrawal deposit. Withdrawal means taking money out. Deposit means putting money in. And then per annum means per year. So you'll see PA, that means per year. So per annum is per 12 months or per year. So that's another important definition as well. You need to know what per annum means. It comes up all the time. Please don't try and don't forget what per annum means. It's always going to come up. So interest is calculated. So let's go through each of the different types of interest. So we're going to go through simple interest and then compound interest. And then we'll go through our depreciations after. So we'll start off with simple interest. Simple interest is, as it says, simple. This shouldn't be difficult. Interest is calculated only once on the initial amount of the principal. So essentially, the D value here is using this formula here. So the best way to go through this is an example, but essentially interest is earned on the original value and it's added every time. So if D is less than 0, you have a decreasing sequence, which means interest is charged. If D is greater than 0, you're earning interest. This will always be simple interest, will always be this. Why is that? Because if it's not, it's going to be simple depreciation. So Tom invests $5,000 into an account that earns 10% simple interest per year. How much is Tom's investment worth after 5 years? So have a thinking. For those of you who are at home and are watching the recording, not the premiere, I highly suggest pausing this and having a go. Jump back to this slide if you need. So jump back in and have a look at this slide. But I want you to have a go. I want you to pause and have a go. Let's do it at the premiere. You don't really have time to do that. I do apologize, but we're going to go through it straight away. So those of you at home, pause, 3, 2, 1. And now we're going to go through. So we have $5,000 and we want to figure out what the D value is. So D here is going to equal V0, which was 5,000, multiplied by R over 100, which is 10 over 100, which is going to equal like 0.1. And therefore, we are going to get a value of 0.1. That'll be 10%. 10% of that will be 500. So our simple interest is going to be 500. So then we have our formula of Vn plus 1 equals Vn plus 500 with VO equal to 5,000. So we can just use nth term here and we can go, all right, V, what are we looking at? 5 years, V5 equals 5,000 plus 5 times 500, and we get a value of 7,500. Important with finance, you put the units on at the end. It's really important you have the units at the end. You always need to put the units on. So that's the value of the investment after 5 years is 7,500, And that's how you go about that question there. So simple interest, simple question. I'm going to be honest with you, simple. If it has simple in it, it's a very simple way of doing it. It's pretty self-explanatory. You're not going to need to stress about it. So moving on. There's the answers there if you want to work through it as well. So compound interest. This is where things get a little bit more complicated. Now, what's really cool about compound interest is you can do it all on the Casio with the Financial Solver. We're not going to go through that right now. Financial Solver will be in a little bit, but you can do this in the Financial Solver. But for now, we're going to go through how to do it by hand. So interest is calculated each compounding period from the current total of the investment rather than the principal. So the number of interest periods is the number of years, which is n, is the number of years by the number of periods per year. And then the interest rate is the percentage per period R. So rate per annum divided by the number of interest periods per year. And that's R. So let's go through how to do this because all of those words can be very confusing. So Howard invests $700 and into an account that pays compound interest at 7.1% per annum. Find the value of the investment after 3 months. Now, this question does not give you enough information because it should tell you what is the, when are we getting interest? So it's 7.1% per annum paid per month. So really important, it needed to say the compound interest per month. It didn't say that. So this question is actually wrong in a sense. It needs to tell you. So I've added it in there. Apologies. I should have added that in there when I sort of put this question down. But essentially this is saying, all right, there is 7.1% per annum, but it's paid per month. It's not paid per year, it's paid per month. So having a look at this question, what we first need to say is, all right, what is our percentage per month? Because we're going per month, so we're going, all right, this is going to be 7.1 divided by 12, which is going to equal 0.59% per month. So we have 0.59% per month. Now I need to find each of my values. So you can go about this sort of in an nth term way, because if we think about it, what we're going to get is we're going to get Vn plus 1 equals 0. It's a little bit confusing. So it's going to be 1 point. Actually, that's probably the wrong way to go about it. I'm just going to apologize. That's the wrong way to go about it. It's going to be, it is actually going to be that. It's going to be Vn plus 1 equals Vn times by 1 point, and going back to this, it was R divided by 0 divided by 100. So 1, 2. So it's going to be 0.059 and 0.059 or 0.059. And essentially here, what you can do is you can sort of square it or cube it, but it's safer with compound interest to not do that. It's safer to just say, all right, let's do each of the steps. So you go through each step. So you go through, all right, the first month. So first month is going to be V1 equals 700 times by 1.0059. And I get my value, which would be, apologies, times by 1.0059. And I get 704.13. And then I run through the next two. So I go, all right, V2 equals 704.13 times by 1.0059. And then I would get another value, which would be 70 times by 1.0059. And then I would do that again. And I end up with a value of 712 for our third one, 0.46. So as you can see here, the answers sort of go through it. You can cube it, but sometimes it can be a safer bet to go through them initially. But as you can see there, you can do your nth term. There are occurrences with this where you have to use Financial Solver because the nth term won't work, but as you can see here, you could have done nth term. That's where I was getting a little bit confused. I was like, wait, and I was thinking financial solver. So that's your, that's your answer there. And as you can see, you could have done it by an nth term way as well. Now, how did I get, people ask, how did I get this value here? I used this formula here. So I went, all right, my little r value is this one here. So I had 0.59. So I went 1 plus 0.59 divided by 100, and you end up with 1.0059. That's how you go about it. So now let's look at flat rate depreciation. Whereas this is sort of like simple depreciation, but you just get given a value usually. Again, it's the same thing as simple interest in terms of that it's like a percentage of the original price, but usually you're just given a value. So you go VN, take D. So it says here, Emily bought a car 18 months ago at $2,500, or $25,000, so 250, it was recently valued at $10,000. Assume flat rate depreciation, find the depreciation rate per annum. So let's find the difference first. So 2,500, or 25,000, sorry, take 10,000, and that's going to equal 15,000. So that's our difference. So we have 15,000 as our difference. Now, we want to find it per annum, so per year. How many years have there been? There's been 1.5 years. So let's find the rate per, find the depreciation rate. So let's find that rate. We go 1,500, or 15,000, sorry, divided by, I keep saying 1,500, 15,000, divided by 1.5, and you'll get an answer of 10,000 per year. And then it says, it wants the rate. So this is the value. We want to find the rate. So we want to find the rate off the original. So we're going to go, all right, 25,000 divided by 10,000. And that's going to equal, it's actually the other way around, sorry. My bad. You want to do 10,000 divided by 25,000. And you're going to find a value of 0.4, which is essentially 40% per annum. If I move across, I think I should have that answer. I do have that answer, 40% per annum. So I found that the rate per annum in terms of money was 10,000, but I wanted the actual sort of the rate. This is the percentage. It's asking for the actual percentage per annum, which is 40%. So again, these questions are about finding out what they want. What do they actually want here? They want the percentage. That's what they're asking for. That's what they're going to get. So that's your simple interest version of depreciation. Then we have the value of something decreases as it's produced over, produces more output. This is what we refer to as unit value depreciation. So there's a fixed amount of depreciation per unit of output. So you could say like a printer, once it prints 100 pages, it loses $10 of value. D is the depreciation for every unit of output, and then the unit of output is N. So be careful, the value of N is constrained in real world examples, as eventually a value of an item will be $0 and it cannot be worth negative $100. So it's like a car, and as a car travels set amount of kilometers, it loses set amount of value. You can't say that your car becomes worth negative money. It's not what happens. You don't then just give it to someone and they pay you to take it. That only happens if you crash the car. So really, really important that you understand that this is real world example. It's like it's restrained within that real world example, and it has sort of that, like, you can't go into things that don't make sense. So it has to have its effective life within a real life example. So there's no example for that one, but essentially think of it like a printer. So think of it like a printer, and you say, all right, it loses 10 cents per 100 pages. So you could say D would be 10 cents, so it'd be 0.1. And it's per 100 pages. So N is the value per 100 pages. So you say, all right, there was 2,000 pages printed. If there's 2,000 pages printed, your N value is 20. So you'd go 0.1 times by 20. And you get your value from there. So really important. That's sort of how you go about that there. So you go, all right, 0.1 cents per unit, and there were 20 units. Therefore, because there was 2,000 pages, which is 20 times 100, and therefore we get whatever value that would be. It would be like $2 off the value of the printer. So that's unit value depreciation. That's like an application of that there. Now what we get into is reducing balance depreciation. Now, reducing balance depreciation is going to be done mainly on your financial solver. And we're going to go through an example where you don't use financial solver, but it's quite important that this is mainly going to be done on the financial solver. So the value of something decreases as it gets older, basically a decreasing geometric sequence. So as you can see here, you have Vn plus 1 equals RVN. So as you can see here, you then have another equation that says R equals 1, take R divided by 100, where R is the depreciation rate in percentage. So let's go through an example. A printing press, so again, we talked about a printer before, is purchased for $15,000 and undergoes reducing balance depreciation at a rate of 3.5% per annum. What is the value after 5 years? So how are we going to go about this? We first need to find out R value. So R value, R is going to equal, and it was 1 take, little r, which here it's per annum. We're looking at 5 years, so it's going to be 3.5 divided by 100. And we're going to end up with a value of 0.965. So we get 0.965. We then need to make our formula. Our formula is probably best going to be Vn equals 0.965 times by n times by VO was 1500. So then we go, all right, I want to find after 5 years. So I'm going to go 0.965 times by 5 times by 1500. And, oh, sorry, that's going to be to the power of. I think that was wrong in the last slide because I think I forgot to put subtext. Going back. This should have been subtext, everyone. Sorry, this is an error. I will fix that before these slides are uploaded. That needs to be N. Now, just let me write a quick note in my phone to fix that. I do apologize. That shouldn't have been like that. Change R to supertext. What slide number is this? And this is on slide 84. I don't know why there's two 84s there. All right, we're on slide 84. So that should be supertext. I was like, wait, that does not seem right. It needs to be supertext. So this is going to be, if I fix this up now, apologies everyone. This will be to the value of n times by 1500. So again, this is going to be to the value of 5 times by 1500. And you end up with a value of, I'm going to do that in my calculator. The power of 5 times by, I get 1200, 552, which will approximately be the right answer. So 1200, 552. I think I have the right, yep, $52. So that's what we're going to get there. So that's how you go about that question there. Really important that that's how you do it. All right, so the answer on the next slide, moving on. So now we get into reducing balance loan. This is really where Financial Solver comes into it, and it's really, really, really essential. So this is where you combine geometric and arithmetic sequences. You get a loan. With the loan, what happens is you earn interest on top of it so that you don't earn the interest, you pay the interest on top of it. So interest is earned on top of whatever the principal is at the time. So the loan goes up. Every single time you go to pay it, the loan goes up. Then you pay it. So let's just say you're at $5,000. Take a $5,000 loan. Your first repayment's going to be $300. But what happens is you're earning, there's 1% interest on it. 1%, essentially, when you go to pay that $300, you're actually going to pay it off $5,050. Take the $300 because that has the 1%, which is $50, added to it. You take the 300 off it, it's going to be 4750. Then the next time you do it, you're actually going to pay off 47. It's going to be 9750. That's what you're going to be paying, and you'll be paying 300 off that because that again has the 1% added to it, and that's how you go about that. So that's why these are really, really messy. There is no end term. That's why you have Financial Solver. Essentially, this is always used when you have a big loan, like a home, like a house mortgage. This is where this is used. Now, there's no example right here for this because we're going to go through an example later on. So we will go through an example of this, don't worry. I just want to go through just the last couple of things before we get to the examples that I have at the end. So effective interest rate, these really don't come up much, but they can be tricky to understand. It really just converts what is a compound rate into a flat rate. So if you're earning, or let's just say we're paying a loan and the interest rate is 5% per annum compounding monthly, when it compounds monthly, you actually pay more than what the 5% is. You'll note that if you do a calculation and you say, all right, I have my loan, and if the interest is 5% at the end of 12 months, every 12 months, it would be, go up by X amount. Now, if I actually earn 5% per annum, but it compounds monthly, so it compounds at, 5 divided by 12, sorry. So it compounds at 0.42% per month. That's what it does. Eventually, it's going to reach 5. Overall, it'll be 5% after the 12 months. But it's compounded monthly. It's actually going to increase the loan more. So compounding at a quicker rate, so compounding monthly, fortnightly, daily, the more it compounds, even if overall it's the same percentage, it's going to increase it by more. So what actually did we increase it by? What is the actual interest rate? Because if overall the percentages add up to 5%, but the actual value that was increased is more than 5%. What is that value? Is it 5.1%? Is it 5.2%? Is it 5.05%? What is that effective interest rate? That's what that is. So it allows for comparison between two sort of techniques. So if you go compounding monthly versus compounding daily, you use the calculator. All the calculators now I know with the new updates have them. My calculator doesn't because it used to not, but they all have this formula within them. But you need to have the formula in your data booklet. Your summary book or your bound reference. It has to be in there. This is another non-negotiable. You need to have this in your summary book. The 2022 Northern Hemisphere exam had this in reverse. Usually this goes from your compound to what is your effective. They actually had the opposite. They went from the effective back to the normal. And you couldn't do that on, I believe, this Casio, or maybe it was the team. One of the Casios could not do that by just saying, this is how you do it. They couldn't just do it. They had to know the formula and put the formula into sort of just like the main page and go X where the normal interest rate would have been, and then put equals the effective interest rate and then solve for X. That's what they had to do. But that was sort of difficult for them. It was difficult at the time because it had never been done before. So I know overall it wasn't answered very well. It was difficult for that set of students. For you guys, it's not going to be because you know how to do it. So really, really important that you have this formula in your data booklet, despite the fact your summary book, data booklet, I keep saying data booklet, summary book, despite the fact it is in the Casio. So as you can see here, this is the formula. I need this in your summary book. You need R effective equals 1 plus, and then you have all of this, but essentially your nominal annual interest rate and your number of compounding periods is important. So your nominal annual interest rate is your interest rate per annum. So if it says 5% per annum compounding monthly, you go 5 here, and you go your number of compounding periods per year. This is 12, and this is 12. And that's how you get your R effective. In their case, they were given, 5.2 or something, and then they were given compounding periods as 12 and 12, and they had to find I. So you just put X there, and you put it in a calculator, and you go solve. You write all that out, and you go solve, and that's how you found it. But you needed this formula to be able to do that. So those who didn't have it in their summary book, weren't able to do this question. So it's really important that you have this in your summary book. And then we have two more things, well, three more things technically, but two more sort of things that are pretty cool. So we have an annuity and we have a perpetuity. So these things are very similar, but slightly different. The annuity is essentially where, think of it like a super. And essentially what happens in an annuity is where an account earns interest and there are either withdrawals or further investments. Usually, these are withdrawals. Annuities are generally withdrawals. So, I'm going to change this and go negative D. They are generally withdrawals. They're generally used as like a retirement fund. So essentially, when people retire and they've got a bit of money that's not in their super, it stays in their account and they put it in an account, an annuity account. What that means is that that account earns interest. And so that account gets bigger. But every month or 2 months or 3 months, they take a set amount of money out. That money that they take out is more than the interest earned. So the interest earned might be $100 the first time because it'll be earned depending on what's in there, so it compounds. But then they take out $300. So the principal gets smaller. And so essentially every time the interest they earn gets smaller. And eventually this will reach zero. This will reach $0 and the whole thing will be spent. A perpetuity is different to that in the sense that the money that is earned as interest, that money comes out, but the principal stays the same. So if you earn $150, I don't know, let's just say per quarter in interest on this account, you take out your withdrawal is $150 per quarter. So you're always going to earn the same amount of interest no matter what. It's just you're going to take that interest out every time. So that's why you earn the same amount of interest. It's still compounding and it should be different, but because you keep the principal the same every time, it never changes. Really common example of this is scholarship funds. So you look at those places that always offer out scholarships, and they always offer out pretty large scholarships, and you're like, how do they do that? They have a ginormous perpetuity that gives them all the money they need for those scholarships every year. And every year, those scholarships are pretty much free because it's just the bank's interest. So they've given the money to the bank, so the bank pays them the interest. They take that interest out as the perpetuity, as the scholarship. So that's how that works there. Slightly different, that's how it works. And then amortization tables are the last step. These things you just need to have in your summary book. I'm not going to go through them in detail because they're sort of the last step. And for those of you who haven't done financials, most of you, this is the last thing you do. So I'm not too worried about going through them today. But essentially, they just show either compounding interest or compounding reducing balance loans. They just show that in a sort of a table sense. So as you can see here, the balance of the loan, it says the payment amount, the interest paid. So there's interest that was added on top of this, and then how much the actual principal went down. So you take this away from how much you paid because you're paying off that interest. And then as you can see, the principal went down to that. Same thing, you're paying off the same amount. This time the interest got smaller because it's a smaller principal, and therefore you paid off slightly more, and so forth, and eventually get down to zero. So that is an amortization table. Now, I think the best way to learn financial, as I've discussed, is to do practice questions. So once you've done your textbook, you need to move on to exam-style questions, SAC-style questions, because that is how you're going to learn. So I've set up one, two, 3 questions here. We're just going to go through them. I'm just going to go through them and just continue on. For those of you who are at home and are watching the recording rather than the premiere, this is the first one. Take a quick screenshot, go through this one. This is the second one. Take a quick screenshot, go through this one. This is the third one. Take a quick screenshot, go through this, and then come back. So pause your video now, come back, and we will go through the answers for you. Those of you at the premiere, we're just going to go through it. So a computer is purchased at $1,750 and depreciates 20% per annum. Calculated monthly using reducing balance method. The computer has a scrap value of $700. How long will the computer last before the value is less than the scrap value? So once it reaches the scrap value, it's no longer useful. So the best way to go through this is to use your financial solver. So how are we going to use the financial solver? My big tip for this is whenever you use the financial solver, you write down on your book what you use. So I'm going to write down in my question, and this is working out. This counts as working out. You go, all right, n equals, well, I want to know n. I don't know how many months it is. So n is months or whatever period it is, number of periods. I don't know the number of periods. So n is my question mark. I'm going to go I equals, and this is always, you put this always in as per annum, 20%. All right, I want to know my previous value. So this will be my principal value. My principal value is 1,750. Now, really important, is this negative or is this positive? Because did I, give the money to the bank or spend the money, or did I gain money? I spent the money. So this is going to be negative. Then it's how much are the payments? Well, there's no payments here. I'm not adding money to it or taking money away from it. So that's 0. What is my future value? I want to know when it's worth $700. Now, 700 is positive because that's how much it's still worth. So that's how much money I've technically still got. So I want to know when it's worth 700. And then my PY/CY, as I said, it's a bit useless. You just put it as the number of periods. So the number of periods within a month. So I'm using 12. So number of periods within a year is 12 because I'm using months. If I was using quarters, I put 4. If I was doing yearly, I put 1. So that's what you put in both of those boxes. So that's my working out. I then go to my calculator and I do it in my calculator, and you'll find that your answer here, complete manually with Financial Solver, I get the answer of 55 months. So how long will it take for the computer to be less than its scrap value? That's 55 months. So really important. Now, this answer here, I believe, is something like 54 point something. Let's just say 54.8. I don't know what the exact answer is, but I think it's something like 54.8. And so when you get 54.8, you need to be like, all right, I know this is going down. So as this is going down, I need to say, all right, because this is going down, like, I need it to be below that value, and it's done monthly. At 54 months, this isn't going to be below the scrap value, but at 55 months it is. So therefore, at 55 months, that is going to be my answer. Not 54.8, because I want to know at the exact month, because you can't be halfway through it, because it's compounded monthly. The other thing here that I probably got wrong was I need to put negative percentage in, sorry. Why did I do negative percentage? Because here you're actually going down. You need to make sure that you know that it's not earning interest on top of it, because this hasn't been put into a bank. So it's really important that you understand this is going down, like that. So you actually have to put a negative on the percentage there. It's one of the rare cases you do. I forgot to put that in on the other part. Apologies. So moving on. This is the Northern Hemisphere exam 2021. So what we've got is Anna has taken out a personal loan. Interest for the loan compounds quarterly and makes no repayments. Apologies, I'm getting a phone call. I say that interest for this loan compounds quarterly and makes no repayments. After 1 year, she owes $5,328.16. The effective annual interest rate for the first year of Anne's loan is closest to. So, how are we going to go about this question here? We need to know the effective interest rate. But what's important here is that we haven't really been told what is the normal interest rate. So we're actually going to have to find both. How do I do that? I go to my Financial Solver. So I actually don't have the answer to this here. So I'm just going to discuss how we go about it, just because, just for the time's sake, I'm just going to discuss how we go about it. This is in the Northern Hemisphere 2021 exam. The answer here is C for those going along at home, but you can go there and sort of go through the working out. But how do we go about this? First of all, I'm going to go to my Financial Solver, and I'm going to put in n equals 12. I'm going to put I equals, I don't know. That's my question mark. I'm going to put previous value equals, it's a personal loan, so positive 5,000. I'm going to put PMT equal to 0 because there's no. I'm going to put my future value equal to negative 5,325 and 14 cents. And I'm going to go CYPY equal to 12. I'll find this percentage. Once I find this percentage, whatever it is, I then go and put this in my effective interest rate formula here. So I put that as I. So I would put whatever that was there as I. So put that in here. Then I put this as 12, this is 12, and I get my effective interest rate. And what you'll find, this is a 2-step question, and you find that your answer there is C. Now, just because we're pushed for time, pushing on. Next one, Ruby borrowed $35,000 from a bank. Interest is charged at a rate of 4.75% on a reducing monthly balance. The loan is to be repaid with 47 monthly payments of $802 and a final payment that is to be adjusted so that the loan is repaid exactly at 48 months. So what it's saying is if I pay $802 for 48 months, I'll pay too much. So at 47 months, I need to then stop and go, all right, how much will I owe with the interest of the last month? And you pay that off. So the way of going through this, I'm just going to show it on the page, is it's 2 steps. So the first step is to go, what do I owe after 47 months? So 47, 4.75, 35,000, take 802. And the future value is what am I finding? This is what I'm finding. This is the one that will be left blank. And then you find it in your calculator. So CY, PY 12, you end up with this answer here. So then on the final month, you say, all right, I've got 1 month left. I want to pay it off after this 1 period. So 1, I serve 4.75. I put in this value as my future value. And I say it's positive now because it's still a loan. Like I still have that money. Then I say 0 is my future value, PY, CY, and I go, all right, what is my payment? This is the thing that is blank. As you can see, this payment's actually higher. I actually need to pay a little bit more in the last month to get it done. So the final payment here is $805.57. And that's how you go about that question there. So they are the 3 practice questions I put there. If there's any quick questions about those and you're at the premiere, you can ask those right now. I'm going to move on to tips and advice. And yeah, so that's everything for finance. There's a lot more to finance than that, but I just wanted to give you sort of the little bit higher in-depth, introduction into finance. That was probably more in-depth than what we usually do at this point, but I think that's sort of I think that's more necessary to be a little bit more in-depth on finance at this point in the year because, you've done data. There's no point going over data for the whole 2 hours. I think it's better to go over finance for half of it. So in our last 5 minutes, let's go over tips and advice. So these tips have been in these slides for a very long time, but I really like them, so I didn't really want to go ahead and change them. I think what's important, first of all, is the study design has changed this year, and I didn't change the image for it, but there is a new study design. It's new content, and when I say new content, there aren't drastic changes. They've removed the causal and causation stuff in data, which we've already discussed. Nothing changed in finance. And then obviously the modules, there's no modules anymore. You now only do matrices and networks. They've removed the choice. There was choice to do other ones. What's really important about those is matrices have removed simultaneous equations. So if you're looking at past exams, and please don't use someone else's past summary book, but if you've got someone past summary book and you see all this simultaneous equation stuff, that's all gone. They've added in Leslie matrices. It's the only thing they've really added to the whole topic, the whole of further. So it's really important you sort of read through it and you understand that. Leslie matrices are not going to be asked anywhere in old exams, so you're going to need to find those when you then go to sort of practice at the end of the year. So that's just one of those things, and it's spelled L-E-S-L-I-E matrice, or matrix, probably the best way of doing it. Matrix. It's a Leslie matrix. So it's the only thing that's brand new in maths this year, in further maths or general maths this year. So that's sort of the difference. It is a new study design. It is just important you read through. They have reworded a few dot points as well. Hasn't necessarily changed the content. It's just the rewording of them. Get really cozy with your Casio. And I think this is really, really important. Your Casio is going to be your best friend, and your Casio is going to have all your answers for you. So get to know your calculator like the back of your hand. Know how to use things, all the shortcuts, everything. If there are things that you always forget how to do in your Casio, write out instructions in your summary book. Write them out and say, all right, this is what I actually need to be able to do. This is how I go through it. Step 1, step 2, step 3, step 4, and go about it that way. Write your own bound reference. We've already discussed this, but you need to do your own bound reference. And it's super important that you go ahead and you do it yourself. I'm a big advocate for writing it. Really, really big advocate for not typing one out. I know a lot of students love to do it, but you should write your own bound reference. It shouldn't be something that you type. It should be something that you write down. You learn more from writing than typing. So please try and write it out. Get yourself a good book that your teacher says will be allowed. I don't remember the exact rulings on what type of books are allowed. I know it's just to be within A4 size, and you can't have anything that's like poking out. But just show them what you're going to get them to approve it, and then go ahead and do it. And please keep on top of it. Don't fall behind in your summary. Don't say I'm going to do all my summary at the end of the year. It doesn't work. Stay on top of it. Have each section done before each SAC or just after each SAC. So then you sort of move into the next one and you just sort of go, all right, now data's done. I'm going to move on to finance. You're on school holidays now. Best time to do it. So get that data section done. And then you can move on to finance and be comfortable that you're just moving on to finance. This is a person who typed out theirs. I don't like it, but it's just an example that was in there and I didn't want to get rid of it. Keep on track of your mistakes. I do like this. I did this come the end of the year when I started doing more exams. I didn't do this throughout the year. I think when you start to do exams, which won't be for a little while, start to keep track of where you make mistakes. Further is not a very broad subject. It's not like methods or Spesh where they can ask a breadth of questions that just seem so different. They use the same techniques, but they're so different. Further isn't like that. Each sort of subset of questions, there's only really like one little subtopic. There's only really 2 or 3 ways they can ask a question on it. So there's actually not that many question types. Once you do enough practice exams, you will have touched every question type. So it's really important you do enough practice exams to sort of know that. You do them as a quality practice exam and you keep track of where the mistakes were. Because if the mistakes are all in the same section, you need to change something. Work hard, but work efficiently. When I say that is to work on sections you struggle in. So focus on areas you struggle in. Financial, if you really, really struggle with financial when you do it next, or if you're doing it now and you don't get the SAC mark you want, you need to work on it. You need to spend time on it afterwards. Even if you're not doing that topic anymore, don't go back and do data because you got 90% on the SAC and you love it. Do financial. Do the sections that you struggle with. Do the topics you struggle with. That's the best way to go about it. Especially important if you're in year 12, obviously, things like that. And use your class time wisely as well. Do practice questions consistently. I think you should be doing practice questions now. I don't think you should be doing exams necessarily, but you could be getting I'm sure your school would have a breadth of sort of company exams. I don't implore doing VCAR ones yet, but probably have a breadth of company exams and older ones. Grab those 2012 to 2018 sort of company exams and just rip out the questions that are relevant to your topic. Don't do the exam, just rip out the questions that are relevant and go through and do those. I think that's sort of, right now, it's sort of the best way to keep on top of it. Don't stress about SACs too much as well. The big thing about SACs is that they're just a rank. They're not set in stone. For example, I'll use my example. I obviously ended up with a perfect 50, but I didn't get perfect scores on any of my SACs. I didn't get a perfect score on a single one of my SACs. So it's really important to understand that SACs don't necessarily lead to what your end score will be. Dedicate time to further, or in this case, it's actually general now. Should have updated that. Further at times can seem like there's not a lot of content and you seem like you're getting on top of it in class, but you need to keep on top of it. You need to be dedicating time to doing some practice, especially if you want a really good mark in it. Utilize all your resources. Your best friends are your teachers, your friends, your tutors, your textbooks, all of the other things. Have a look at ATAR notes and what we offer. Make sure you utilize all your resources this year and don't sort of leave something behind. And look after yourself. Take regular breaks. Be realistic. Keep on top of things like sleep and exercise. We've heard this 1,000 times. I'm not going to dawdle on it. But nonetheless, that's sort of everything for today. I'm just going to thank our sponsors. So obviously, these get to you free because we're sponsored by some great universities, as you can see there. They're all on the page there. We have some info sessions on them, so please have a look at those as well if you're considering any of these unis or you haven't even considered them but you want to learn more about them. Please go and have a look at those info sessions. They're great unis. There'll be recordings up for them and there'll be premieres for them, etc. But otherwise, good luck for the year. I'll be seeing you around. I run these lectures pretty regularly.